Welcome to Chapter 5, Section 2, 5.2. We're going to talk about compound interest today. So let's say hypothetically that you took college algebra or maybe a math class in high school and you remember everything there is to know about compound interest. There's nothing new today. There's really not much calculus today. We're just going to be kind of reviewing a little bit on how compound interest works, and it's going to sort of tie into the previous section, sort of tie into the next section. Let's get going. Okay, so recall that continuously compounded interest, there's kind of two ways that we talked about interest formulas. One of them was interest that compounds like annually, interest that's semi-annually, compounding quarterly. But there's also this thing that's called continuously compounding interest, interest that is literally always growing as opposed to only growing twice a year. Okay, is A of t equals P naught e to the RT, which is exactly the same formula as exponential growth in the previous section. Okay, so this is just a specific application of everything we did in 5.1. So P sub 0, P naught, however you want to say it, is going to be our initial investment. E is Euler's number. R is going to be the interest rate as a decimal. So make sure to convert this to a decimal. If you don't convert this to a decimal, you're going to have some wacky stuff. And then T is in years. All right. Lots of arrows. Arrows for everyone. We love arrows. Okay. So again, if you remember how to do this, then great. Go stop the video. Get out of here. Just start doing the homework problems. If you say, Jason, I don't remember this at all, then this video is for you. Okay. Let's do a problem. Example 1. Let's say that $1,000 is invested. Can't believe I just told my students to leave class. $1,000 is invested at a 5% interest rate, compounded continuously. I'm going to be very lazy and use some abbreviations here. Compounded continuously. Okay, and let's do some problems. Find A of t. Find the amount that is going to be in this account after t years. So we just identify all of our variables, right? P naught, this is how much we started with. R was the interest rate. And that's all we need to find, okay? So this right here, this is how much we're investing. This is our initial amount. This is our P naught. That is the smallest zero I've ever drawn in my life. This is our interest rate. This isn't R though. Remember, R is a decimal. This is not a decimal. This is a percent. Okay, so P naught equals 1,000. R is not 5. It is 0.05. So watch out for that. Otherwise, you're going to have a 500% interest rate, and then you are going to be really, really rich. And we don't want you to be that rich, okay? So A of t is just P naught, which we said was 1,000. E to the R, which we said was 0.05, times t. That is the amount that's going to be in your account after t years. All right? And yeah, that's it. Part B, how much will you have after 6 years? So we invested $1,000, 5% interest rate. We come back 6 years later and say, how much do I have in this account? You just use the formula. This is the amount that we have after t years. So after 6 years, that's just plug it in for t, right? This 6 over here is just our t value. Plug it in and let the mathemagic work itself out. The amount after 6, replace all the t's with 6's, is 1,000 times e to the 0.05 times 6. And you type that into a calculator. All right. And you're going to get an answer, or we're going to round to the nearest cent. We are not going to have fractions of cents, okay? So we're just going to round a little bit. And what we're going to get is 1,000 times e raised to the 0.05 times 6 1349.86. And then you don't want to make your math teacher sad. You're going to squeeze in a dollar sign right there. So after 6 years, we got an extra 350 bucks. All right. Not the biggest interest rate, especially if you think about the 2 or 3% that's going away every year due to inflation. But yeah, it's more than we had before. Let's do part C. Keep doing more and more of these. More variations on this. After 6 years, at what rate will it be growing? And before any of you cheeky students out there, because I do see some of these on these quizzes, don't get too cheeky with me. Don't just say, it'll be growing at a 5% interest rate. That's what rate it'll be growing at. That's not what the question's asking, okay? It wants how many dollars per year is it growing at this point, all right? And so there's an easy way to do this and a hard way to do this. At what rate? That's the derivative. Anytime you see rate in this class, derivative. Identify that, okay? We could look at the function. We could look at the function, we could find the derivative and plug things in. But, wait, how come I can't undo it? Oh, there it is. The undo button was undoed. There's an easier way. Remember to the previous section, which for me was a week ago, but for you should hopefully be pretty recent. The solution, this is a solution of a differential equation, right? Remember that y prime equals k times y is the same as y equals c e to the kt. Well, this is exactly what we have. So we can save ourselves a little bit of stress. We could just find the derivative and plug in 6. We could save ourselves a little bit of stress by saying, let's use this. Y prime is equal to our k, our coefficient, our interest rate, times how much we have y. Well, how much do we have right here? 1349.86. A little shortcut with differential equations. Okay? So again, there's 2 ways of doing this problem. Either way, you type that into a calculator, you get your answer, and your answer is going to be 67.49. So after 6 years, we have $1,350 in the account. And specifically after 6 years, we're getting about 67 bucks in the next year. So we're making about $67. Let's get the right units per year. And that's the whole thing about exponential growth, right? The more we have, the faster it grows. The more we have, the faster it grows. This is a proportion or a direct, gosh darn it, my words are going out of the door today. All right, they're directly related. That's exponential growth. Okay, so what do we got here? We have our D. Let's do one more. How long until it doubles? Find the doubling time. So it took 6 years to get an extra $350. The question is, how many years does it take to get an extra $1,000? Okay. So we just kind of plug it in and say, okay, we started with 1,000. So, right, this is just asking, when is the amount equal to $2,000? Plug in and we solve. Okay. So 2,000 equals 1,000 times e to the 0.05 times t. Solve this exponential equation. Always the steps are the same. We divide everything by 1,000. We've been doing a lot of these now. We take the natural log of both sides. and we divide by the coefficient. We get that t is going to be approximately the natural log of 2 divided by 0.05, which is 13.86. So this is going to take about 14 years. If we want to invest $1,000 at this interest rate and we want to double our money, we're going to have to wait around for a while. Okay, so about 14 years. Yeah, give a little sad face here. Takes too long for me. All right. And that's his first problem. Good luck.